Welcome all. Today we are going to study analysis of variance, otherwise ANOVA. ANOVA is developed by Professor R.A. Fisher in 1920s for his experiment. Today we are dealing with ANOVA. Most of the persons ANOVA and its derivations are so difficult for them. Through this class we are learning what is ANOVA, what are the things in ANOVA, and what are the classifications in ANOVA and that derivations also. First of all, for ANOVA, I take the reference from the book Fundamentals of Statistics by S.C. Gupta and V.K. Kapoor. We can go to ANOVA. ANOVA, analysis of variance, that I said earlier. First of all, for what purpose ANOVA is used? ANOVA is used for comparison of more than two means. Okay, more than two means. We also learned that Z-test and T-test. We use Z-test if we have to compare two means. We use Z-test. If the population is, if the sample size is small and the sigma square or the variance is unknown, we use T-test. Then where this ANOVA came? ANOVA is used when there are more than two means. Then the first question is, why can't we use Z-test or T-test at this situation? The main reason is, for conducting a test, we have a level of significance or called probability of type 1 error. For each test, we have a fixed level of significance. For an example, we can 5% level of significance. We have 95% of confidence. Right, we have 95% of confidence. For each test, there will occur one type 1 error at a probability of 5%. Let us consider x1 bar, x2 bar, x3 bar. Here we have three means. If two mean, we can go through Z-test or T-test. Here we have three means. We want to test this equality, that x1 bar equal to x2 bar equal to x3 bar. We want to test this. For here we can use Z-test or T-test. For each test there will occur one type 1 error. For one type 1 error is 5%. For the next test, the type 1 error will increase. As the test increases, the probability of type 1 error or the level of significance also increases. As increasing the level of significance, the confidence level also decreases. We have to maintain a 95% of confidence level. If we consider more T-test or more Z-test for comparing two more than two means, there the confidence level will be less than 95%. That will affect our test and the confidence level will also decreases. So we are conducting one test, that name is ANOVA, for comparing more than two means. Also the time consuming is less, and the next is expenditure. The expenditure is also less. As conducting one test, we will only have one type 1 error or the level of significance will be, we can make it as lower than 5% and making the confidence interval high. Okay, we can come back. For first we said that ANOVA, analysis of variance. The second we said that it's comparisons of two more than two means. Okay, it's comparisons of mean. Then where the term variance? Here if we said that okay, these sample have different mean and that sample have different mean, by seeing this mean we can say that the samples has a variation or sample has a variance. That why Fisher used comparisons of mean. By seeing their mean, we can say that there is a variation and they have a variance. Okay, next we can go to assumptions of ANOVA. The assumptions of ANOVA are, the observations are independent. The first assumption is observations are independent. The observation must be independent. Only at that time we can do ANOVA. The second assumption is the second assumption is about the parent population. The parent population must be normal and it follows a normal distribution. The second is various treatment and environmental effects are addictive in nature. This we will see in our derivation. That is, if we say at this time, this will make some complex. Okay, I will say that the variance can be split into more than one terms. That is, the total variance is split into two or more terms. At two or more variants, we can split the total variation and make it as a sum. The only one condition is that taking the sum of the whole variance, we must get the total variance of the experiment. The next, ANOVA can be classified into mainly into two. One-way classification and the other one is two-way classification. We will see what is a one-way classification and two-way classification in detail. First of all, we want to understand, okay, what is one-way classification? One-way classification for an experiment. Okay, we are considering an experiment that in agriculture field, we have some crops. We have some 2 or 3 crops. We are applying one fertilizer in it. There is only one treatment are applying, that is one fertilizer is applying. That time we considered as one-way ANOVA. Here in two-way classification we are applying two treatments, that is one is one fertilizer and the other is one pesticide. The effect of two will affect the total yield, right? The two treatments will affect the total yield, that we will see in detail. We just want to know ANOVA has two classification, one way and two way classification. For doing ANOVA derivation and understanding equation, we must know one is Cochrans theorem. First of all, we want to understand that what is that Cochrans theorem. The Cochrans theorem states that let x1, x2, etc. xn is a random sample from a normal population. That population follows normal 0 sigma square, that is mu 0, that's mean 0 and variance sigma square. Let summation xi square equal to q1 plus q2 plus etc. qk, where qj, the general term as qj is quadratic form in x1, x2, etc. xn with degrees of freedom rj is equal to j1, 2, etc. k. The qj by sigma square is chi-square variable with rj degrees of freedom if and only if summation j is equal to 1 to k rj equal to n. We won't understand, okay, there are some terms, we are considering some things, there are some terms chi-square variable, some things like that. Just understand that here we are saying various treatment and environmental effect are addictive in nature. For an example, we said that the total variance is classified into two or more variants. The each small variance, that is, we can write as capital sigma square is equal to small s1 square plus small s2 square plus small s3 square. The small s1 square has a degrees of freedom. The small s2 square has a degrees of freedom. The small s3 square has a degrees of freedom, like this. Sigma square is equal to s1 square plus s2 square plus s3 square. Here the total variance we have divided into three small or three component variants. The s1 square has a degrees of freedom, the s2 square has a degrees of freedom, and s3 square has a degrees of freedom. Here in Cochrans theorem, we are saying that by adding these degrees of freedom, we must get the total degrees of freedom. That's we are saying. The summation of degrees of freedom, we must get the n. That is the total degrees of freedom. That's just the Cochrans theorem. The summation of all the degrees of freedom, we must get the total degrees of freedom. And the next, for ANOVA, we want to learn EF statistic or EF. Okay, in ANOVA, we use F test. F test like F is equal to variation between sample divided by variation within the sample. Okay, variation between sample divided by variation within the sample. Simply in ANOVA derivation, we will write it as MSC divided by MSE. Okay, we will see what these terms indicate. Then next, for studying ANOVA, we want to know what is null hypothesis for the ANOVA and what is the alternate hypothesis for that. In ANOVA, we use the null hypothesis as mu1 equal to mu2 equal to mu3 equal to etc mu k. At the alternate hypothesis is at least one mean is different. This is the null hypothesis and this is the alternative hypothesis. That's what the introduction for ANOVA. And what we learn is the ANOVA is analysis of variance, and the analysis of variance is developed by R.A. Fisher in 1920s. For comparisons of more than two means, instead of the t-test and z-test, we can use ANOVA. There are three assumptions for the ANOVA, that's the observations are independent, the parent population which follows a normal, and the various treatment effects are additive in nature. And we see there are two types of classifications, one-way and two-way classification, and the Cochrans Theorem states that the sum of degrees of freedom is equal to the total degrees of freedom, and we see that F is equal to variation between the sample divided by variation within the sample, that is the variation between each sample divided by variation within the sample, that is the observation variance. Next, we see the null hypothesis and alternative hypothesis. These are the things that, or the introduction to ANOVA. If we have this, like what is ANOVA, what are the assumptions, and what are the theorems, or what are the main things that used in ANOVA. If we have this in our hand, we can do ANOVA, or we can study ANOVA so easily. The next main thing we want to remember that ANOVA technique is now designed to test the equality of several population variants. Rather, its objective is to test the equality of several population means or the homogeneity of several independent samples mean. Okay, these are the introduction to ANOVA. And the next thing I want to say is, by conducting the experiment by R.A. Fisher, he conducted it on agricultural field. The experiment or the test was developed by conducting the experiment in agricultural field. Mostly the terms in ANOVA are related to agriculture, like plot, block, treatment, and etc. etc. The terms and the things related to ANOVA, we will learn it in the next class.